Good day to all. This is Remya Rose, Assistant Professor, RMD Engineering College. This video will be looking at analyzing the efficiency of algorithm, which is the topic under design and analysis of algorithm. So before learning on calculating the efficiency of algorithm, everyone must be aware of what an algorithm is. So algorithm is nothing but a step-by-step instruction which we write to bring some solution to a problem. So there are different forms in which you can make a design on what we are doing to solve a problem, which could be an algorithm, which could be a flowchart, which could be a pseudocode, and so on. If suppose we are going to make a flowchart with respect to bring a solution to a problem, we'll be using certain geometric shapes like ovals, parallelogram, diamond, and so on. Algorithms are the very basic thing which we do before we go for the original coding. So these are the step-by-step instruction with normal language we write, like what we are going to do, right from the beginning to the end, or right from getting input to producing an output. So it could be generally defined as algorithm could be set of instructions, and those instructions should be finite, and each instruction should be unambiguous. Unambiguous in the sense when we are writing an algorithm, it should be much more clear enough that somebody reads it, understand it, what is really happening, and those algorithm could be easily converted to be a code. And always an algorithm will have three basic part. One is the input part, which you call it as the initial part, and the intermediate one, which is the real processing factor or the computation part, and the final one is the output part. So you start your algorithm, you write some instruction related to the input, what is your input to be, what is the original legitimate input, and next will be the processing, and then once after the input has been processed, what will be your possible output be. This is actually the definition of an algorithm, and that is what explained more clearly here. So always your algorithm will have a basic thing of three parts, which you call it as the input part, which the algorithm tries to read input from the user. Then it will perform, actually this is the intermediate step, which performs certain computation, which could be an arithmetical operation or any such operation, and finally it prints the result and output it to the user. And your algorithm need not be only sequential, it could be some conditional statements be included, or it could be some looping statements included based on the scenario of the problem we are solving. So conditional statements, obviously, which tries to check on a condition. If it is true, we jump to certain steps or we skip certain steps. So we will be using go to step 2, go to step 3, go to in our algorithms. And repeat operations mainly work on certain steps be repeated or looped again and again as per the operation is to be done. And now we are going to learn on analyzing an algorithm. So in simple language, I will tell you what is analyzing an algorithm be. Analyzing an algorithm is nothing but investigating on an algorithm. You are just trying to check how well your algorithm works. So that efficiency is going to be calculated with respect to two things. One is the time complexity and other one is the space complexity. So without reading all these things that is shown in the PPT, I'll just tell you what a time complexity and what a space complexity is. See, time complexity is nothing but the amount of time the algorithm takes to execute, or the time which it takes to convert the input into an output, or you can merely tell it as an execution time. And space complexity is nothing but how much extra amount of memory space the algorithm is trying to utilize. So based on these two things, we can calculate the efficiency of an algorithm. And when we are calculating the time complexity, irrespective of the amount of time the algorithm takes, there are certain other external scenario where the speed of the execution depends on the machine, which is actually not well formatted, or it may be depending on certain external features, the execution time may vary. So what is mainly considered is for every problem there will be one basic operation. Say for example, if it is going to be searching, the basic operation will be comparison. If it is going to be matrix multiplication, the basic operation over there is multiplication, some arithmetic operation. So every problem has one basic operation. So irrespective of the other external things, the execution time is calculated based on two things. One is the basic operation and the number of times the basic operation is executed. So I can also say that always the execution time depends upon the size of the input. Say for example, if you are trying to sort a list, if the size of the list is going to be small, the execution time is going to be the shorter one. Easily you can sort it. If it is going to be a longer list, again it takes a little more of time. So always your execution time depends upon the size of the input, and it depends upon the basic operation. So two things the execution time depends on. One is the basic operation and the number of times the basic operation is executed. So that is what given here. So the time efficiency or the execution time could be the basic operation as well as the number of times the basic operation has been executed, which tells you the time complexity. And next one is the space complexity. So I told you, when we want to work on certain codes, or when you want to try to solve some problem, obviously we need some space for executing the program. So there are two things. One is the fixed part and other one is the variable part. Fixed part is the amount of memory that you're going to use for the instruction itself, maybe the byte code. And the variable part is the amount of space that you're going to use for your input as well as the output. So this one varies depending upon your problem type. So based on two things, we are trying to calculate the efficiency. One is the time, other one is the space. So how fast your algorithm can work, that depends on a formula which says that execution is equal to basic operation into the number of time the basic operation is executed. And the space complexity is that apart from the memory that you're going to use for the byte code, how more amount of space that you're going to utilize for that. So depending upon these two factors, we can calculate the efficiency of an algorithm. Thank you.